Welcome to springlib.
This is the answer to Chapter 12, problem number 33 from the Smith Organic Chemistry textbook. And in this problem, we're asked to draw the products formed when each of these alkenes is treated with hydrogen gas and palladium on carbon. And we're also asked to be sure to include stereoisomers. And so for A, there are no stereoisomers, and the answer is just hexane. Okay? So for the other three of these, we are going to have to worry about stereoisomers. So remember that hydrogen gas and palladium on carbon is going to do a syn hydrogenation. So both hydrogens are going to come from the same side of the molecule, but there's not any control as to which side that actually is. So for example, in B, if the hydrogen, the two hydrogens come from behind this molecule, and add to the back of these two carbons that are currently double bound. If they come from the back, that's going to push this methyl group to the front. Whereas if they come from the front, that will push the methyl group to the back. Okay. And then so in C, it's going to be exactly the same thing. So if the hydrogens come from the back, the substituents on these two carbons will be pushed to the front, which we express with wedges. And if the hydrogens come from the front, then these substituents will be pushed to the back, for which we use dashes. So then D is exactly the same way. So if the hydrogen comes from behind here, it's going to be on a dash. And then the isopropyl group will be on a wedge. Oops. It's a 3 and that one's a 2. Okay. Whereas if the hydrogen comes from the front, it's going to be on a wedge. And the isopropyl group would then be towards the back and on a dash. So there we go. There's the isopropyl group. And so that's the way to solve this problem. We just need to remember that hydrogen gas and palladium on carbon give a syn hydrogenation. And then we need to account in each of these products for what the product would be if the hydrogen came from the front, and what the product would be if the hydrogens came from the back. And that's the answer to Chapter 12, problem number 33.